afternoon, ladies and gentlemen. Look at me right in your face as soon as I open this. I hope that makes you happy. Today we are going to talk about soil, one of my favorite things. I grew up a country boy in the middle of the United States, and soil has a special place in my heart. I maybe does it. I definitely now knowing what I do, learning through environmental science. Definitely now it makes more sense about growing up in the soil of where I grew up was a huge farming community, and now knowing why it was a huge farming community makes just so much more sense. So by the end of this, hopefully you get thinking about geography and places as well. So today we're talking about soil texture, just the qualities of soil, and how that affects the living environment or the species on that environment. What type of soil has many different impacts. The type of soil affects aeration, water holding capacity, drainage, penetration by roots and seedlings, among many other things. So you're going to kind of find out in today's lecture of why what's the difference between a desert soil versus a tropical soil, or a soil that's around Bangkok rather than in the mountains. Now, of course, you're like, well, duh, desert has more sand. Well, yeah, but how does that actually affect things, right? We're going to kind of get down to that, right? So get excited. We're talking about soil. Okay, so soil structure refers to the arrangement of soil particles into aggregates or PEDs and the distribution of pores in between. Really what we're getting at is soil is really made of three different things: clay, sand, and loam. And depending on each of those amounts of those three types of particles, really dictates what kind of soil you have. It's not a stable property, and it's greatly influenced by soil management practices. That just is natural as well as man-made. Just know that soil can change. Some places that have very beautiful, rich soil, as we'll call, or ability to grow many things, can lose that capacity and turn into a non-rich soil, right? So just kind of looking at these tables are very important here. Make sure you understand them. But each one has different qualities. Each one has a different water retention and availability. Different has nutrient storage capacity, airspace, and primary production. Right, the growing of plants on it. So clay, just to kind of talk to you about, but the ability to hold on to water. It becomes sticky and easily waterlogged, right? Or clay tends to. It'll absorb so much water, and then the rest kind of runs off because, as we're going to find out, clay is very thin particulates. Sand, rain can move very quickly through it, fast draining soils. Why? Because there's just more space. They're bigger particles, so water can rush through it. That's why deserts don't really, hopefully you're thinking in your mind, that's why deserts don't really hold on to water. The water seeps through and then either goes into groundwater or rushes off because it's able to flow easily through sand. And then loam is kind of the perfect type of necessity, or because loam is kind of a mixture of organic materials, enough sand, enough clay, and loam really has the ability to kind of has this medium quality to it, where it doesn't, push water away, and it also doesn't allow it to seep through very fast. It's this nice in between, and you can kind of see same thing with airspace and primary productivity. It's kind of just in the middle, which makes it the best for growing things. All right. So stay with me. Soil profiles vary from ecosystem to ecosystem. I kind of mentioned this in last lecture, but depending on where you are, what type of species grow upon it, what type of topography that you have, really affects the type of soil you'll get. These are just 5 different types, but as we can see, desert soil between grass soil, coniferous forest soil, they're all going to have different types of soil. So it's important to understand that and how those affect it. We'll kind of get into the soil around Thailand and how that is affected. And just know that the soil around Bangkok is very much different than the soil that's in maybe a little bit slightly north where there's more rainforest. We'll talk about that. All right, moving on. Okay, very important table here. Just know that the structure of soil is very important to what type of plants or what type of organisms can live in that soil, right? We have sandy soil. It has coarse texture. We have loamy soil, which has a moderate coarse. It's kind of in between loamy soil. I'll state once again, loam soil is the best for growing most plants. And then we have clay soil, which is very fine texture. It almost is so fine, it can get kind of silty, where it almost packs in too much, where it really hinders the growth. And remember, water will fill it up to a point, but then the rest of it just washes off very easily because, there's such fine particles that the water cannot seep through. Same thing with air. So do know that loamy soil is the best. I'm going to let you you can pause me. I want you to go through this table yourself because as you're going to see, oops, didn't mean to do that. I was trying to make me smaller. Let me shrink myself. Oh, no, help me. No, sorry, stupid joke. But I want you to go through this table yourself. Pause me here and go, because I think in your workbook you definitely have to answer some questions on this. Put some good thought into it. Which one allows more aeration? Which one would be better for growing? I think I've kind of mentioned that, but really read through this and kind of see how the differences in between soil are, and maybe you understand why deserts don't grow soil very well. Even if they started receiving a little bit of rain, it would still take a long time for that soil to build up. Do know, I guess we'll wait till the next slide, but go ahead and pause me here if you need to, but I'm going to move along. And oh my God, I'm back. All right, there we go. All right, so soil permeability, the ability for things to go into the soil, such as water or even air, we'll talk about. The rate at which air water can flow from the upper layers of soil to the lower layers. We kind of talked about this, but clay particulates are very small, so they have low permeability. And then what does get through it really gets locked in there. So clay soils tend to not have a whole lot of aeration in them or water seepage in them. What they hold, they'll kind of hold on to, but not a whole lot of water seeps through it. Clay soils tend to make not very good growing soils, right? Because it's fine. It's just too extreme to that point, right? Sand, on the other hand, has very large pore space, right? Because they're bigger particles. So minerals, I guess it allows minerals to leach through the soil. So if it rains, if the sand becomes really hard, then the rain can flow off it very easy, or it just seeps right through it because it has that large pore space. Same thing with air. Loam soils, once again, are ideal for agriculture because they have good permeability and good nutrient content. It's the nice in between. It allows the water to flow through it, but not too fast where it kind of holds on and retains that moisture. Okay. Important to know. Obviously, this is a big one. We're going to speak on this when we get to the agricultural unit, which is very important because why can't we just grow rice or corn all over the globe? Well, there's soil reasons, right? Soil particulates, just kind of know the size of how scientists classify them. You should kind of know this, right? This is the scientific side. But clay is usually less than 0.002 millimeters in diameter. Silt, on the other hand, is even more, 0.002 or a little bit larger, I guess. Sorry, I had that backwards. To 0.05 millimeters in diameter. Maybe I always thought country boy. Sand is 0.05 to 2 millimeters in diameter. So, this little scale really kind of gives you the properties of or how scientifically we place these materials. Soil texture is determined by, let me shrink myself again, the relative amounts of the different types of sizes and mineral particles, right? It just depends on the mixture of these. A good soil will have an equal kind of amount of all these particulate sizes. If it becomes too much of one thing, it becomes bad. A fairly equal portions, I guess I just said that, then it is called loam. And soil texture affects the fertility and primary productivity of an ecosystem, right? The type of soil you have, look at me playing around with that. But just know that, once again, you want a nice medium of all these soil structures to able to grow agriculture thing. And we're going to talk about that. Again, I'm alluding to, I know the future, but look, we're finding out, to grow certain types of foods on this planet, we don't have the whole world. We only have a small fraction of the land that you can grow particular things on. And with that, as we're going to find out in 5.2, we're losing our good soil. We'll greatly discuss about how we are just losing that beautiful loam that we once had on this planet all over. And we'll understand why. Soil texture triangle. Okay, I'm gonna move myself again. Look at this. I'm just having fun all over the place. This is important. You're going to have an assignment on this. I don't know if I'm assigning it to you today. If you're assigning it today, good luck. Have fun with it. I don't think I'll assign it with this lecture because I want you to do your lecture book. But you will have an assignment on this. This is how you find out what type of soil you have. You use this soil texture triangle. Now, hopefully, if we do start school anytime soon, we will actually have a lab on this, a fun dirt lab, as I call it, which will kind of go through this. But just know this is how you judge about what type of soil you have, if I can make sure this is right. Okay, so how do you do this? Well, you check out the layers. I'll eventually have you do this, but in my, I think, assignment that I'll have for online, it gives you kind of what percentage of each you have. So let's pretend that on this, well, let's not pretend, but we know this is clay side. Anything going this way is clay side. Anything going this way is silt side, and then any way going this way is the amount of sand percentage, right? So let's say we have a soil that you know is 20% clay, so you'll go up to 20%. So it means that our type of soil is going to be anywhere along this line, but we only have one access point. We don't know where it ends up. Now let's say that silt is equal to 30%. Well, silt is this way, so we go to 30% silt. That means that the number has to be along this line. As long as you know what two percentages are, you know where it fits in. So in this case, it would land right here between, we have 20% clay, 30% silt. That means it is right on the cusp of being a sandy clay loam, sandy loam, or a loam. So this is a decent, good type of soil, or at least pretty close to it, which you perhaps could grow things in. That's really how this works. Now, when you're doing this worksheet, make sure you take the time and follow which direction each of these are going. Like I said, clay goes straight across. Silt goes down this way, so you have to follow a line. It goes down this way. And sand, going this way, follow the lines going up that way. Those will kind of tell you where it's at. Now, if you have, 20% clay, 50% sand, well, how much silt do you have? 30%, right? Easy math. You can only have 100% of something, right? So let's give you one more just to help you. But let's say we have a soil sample that shows that it's 50% sand. Boom. So we first find sand. There's 50%, and we see the arrows going this way, or the lines going this way. So that means our soil sample is somewhere along this line right here. And then we find out that it's 45% silt. 45% silt. So we find silt, which is down here. We go right into in between, and it goes this way. Follow an imaginary line to the 50%. Boom! We know that soil is 50%. So I know a lot of you are probably like, okay, got it. Thanks, kind of rolling your eyes at me, but no, I always have somebody always miss a lot of these because they don't take the time to follow a line and understand which direction they're going to. So when you do get this assignment, please take your time, and it should be an easy 10 points for you, okay? Have fun with it, all right? All right, next one. So, and like I said, we'll have a few practices with this, especially I hope when you get back to school and we can actually do a lab on it, because I enjoy the lab. We go check soil samples. All right, next. This is just kind of showing you, this is just the kind of same thing, just in image form, right? What percentage of each is in, right? But exact same pyramid. We won't use this one, but it just kind of gives you an idea. And just remember, loam right here in the middle is the beautiful one, right? This is the one that is most available to grow things. If we have too much silt, bad. If you have too much clay, bad. And if you have too much sand behind my big head here, bad, right? Look at me having fun with science. I love it. But just know that this is just kind of another kind of graphic to kind of help you understand these processes. Okay. All right. And then kind of moving on to kind of what we're finally discussing, and we'll kind of meld this. This will kind of go into 5.2. But this really depends on this. The type of soil you have also will dictate what pH levels you'll get in your soil. And plants, as you should already know, we've discussed, certain plants require certain pH levels, right? If you have a more base soil or alkaline soil, you'll get these plants tend to like them more of a neutral soil, more acidic as it goes on, right? Now, most deserts and rainforests are on the acidic level. Why is this, do you think? Really pause it now. I'm obviously going to give you the answer in a moment, but why do you think deserts and rainforests tend to have more acidic type plants? Cactus are very acidic plants. Many tropical plants need acidic soil. Why do you think that is? They're both extreme, right? It's because of the amount of pH or acid in, or the lack thereof of base or alkaline in the soil, right? And we'll talk about why. Right here. Okay, move my head. Geez, I am moving my head all over the place. But acidification of soils, if I can say that right. Acid precipitation due to industrial pollution is a cause of that, right? We are getting more acidic soils due to pollution. We're just kind of inputting it. But clay soils often have high acidity due to the absorption of water. Really what you have is acids just get stored in them and locked in them, and that's why you'll get more acidic soils there. Acidified soil causes leaching of potassium, magnesium, and ammonia. So if you have areas with a lot of leaching, like tropical rainforest, right? You have a lot of water, and the water seeps through and leaches it gets rid of all the alkaline materials, leaving the acid. That's usually why tropical rainforests tend to have more acidic type soil. And a decrease in pH causes aluminum and iron to become more available to plants, which is toxic to most plants, especially evergreen plants, which lose their needles. So certain trees, like as we're kind of mentioning, evergreen and pine trees, or certain types of pine trees, need less acidic soil, right? I think I say that on there. Let me get through this, and I'll kind of speak on this a little bit again. But fertile soil is not. Oh, okay. No, let's stop there. I'll finish up here. But just know that acidic soils, and then think about why deserts might have acidic soils, right? Once again, it has a lot of sand. When it does rain, it does wash away those alkaline materials. So that's why deserts and both rainforests have very acidic soil, which is not good. You want that nice in between, right? That keeps in its bases as well as acids. And we're losing that. As we're going to learn from this one and the next units, we're losing that due to pollution. We're getting more acidic soil. And we'll eventually talk about how now, when we used to have these, anyway, I'll speak on it later. We'll find out why we're losing all of our good soil, okay? It's important to know, and this will kind of meld into the next unit, but fertile soil is a non-renewable resource. It takes a long time for good soil to form. We'll actually get into specifics of that, but just know that. And once it's gone, if it gets washed away, it's gone. It goes out to the ocean, and we are not going to dig into the ocean, or at least when it gets in the ocean, it gets all it gets a high salinity, right? So do know that once we lose it, it takes a long time to form. Fertile soil has enough nutrients, nitrates, phosphates, and potassium for healthy plant growth, right? It's that nice in between. But then nutrients are leached from the soil and water is moving through. Nutrients are also lost when crops are harvested. We'll kind of talk on that, but just think of that. You grow some corn on it. The corn takes up all those nutrients. Well, then we as people, before agriculture, that corn plant would fall, die, and decompose, and those nutrients would go back. Now we cut that corn up and take it somewhere else, so that soil becomes bare, and that's why we have to use fertilizers now. Then, that moves me to the next point. We now use chemical fertilizers. And there are more sustainable methods of replacing nutrients, including crop rotation, planting legumes, and using organic fertilizers. But we will talk on that in the next lecture, okay? All right, that is it. What am I at? 18 minutes again. All right, well, I'm trying to make this as easy for you as possible. Hopefully you enjoyed this. Do understand, even if you're rolling your eyes like soil is not interested, try, at least know the importance of it. Think of the importance of soil. Okay? All right. Take care. Have fun. See you on the next one.